5. So to just begin with fractions, if I write 5 over 8, what does this say? This could mean, in simple terms, if I give an example, suppose there is a pizza, and the easiest example you may have seen, and I divide it into, say, 8 equal parts, well, basically 8 slices. Now, forgive me for my drawing. So these are 8 equal slices. Yeah, and I could only finish 5 of these slices. Yeah, which means I could not eat the complete pizza on my own. If I had eaten the complete pizza, then it means I ate the whole pizza. So that whole is a whole number 1, because there is one pizza. If there were 2 pizza, there are 2 wholes. But out of this one whole pizza, I could only eat 5 slices when they were divided into 8 equal slices. And 8 equal slices divided is what comes in the denominator. So whatever you have divided that into equal parts, so that number is your denominator. Okay, and you also often heard the term, hear the terms called proper fraction versus improper fraction. Why do you think something is called a proper fraction and something is called improper fraction? Is it like improper means illegal or something? Okay, yeah, Devansh. Or who else also raised the hand? So I'll give chance to Krishna this time.
A proper fraction is a fraction which, like, whose numerator is bigger than the smaller than the denominator, and the improper one is the opposite of that, which is like the numerator is bigger than the denominator.
But why do we call it improper? What is so improper about it?
I
Never wondered.
don't really know.
Anybody knows why? The answer was correct. So if the example that I have given you here, 5 over 8, it's a proper fraction. And if I had just reversed it, I would have called it 8 by 5. So that is an improper fraction because 8 is bigger than 5. But why do we call it improper? What is so improper about it? It's not behaving bad, is it? It's just a fraction. So why do we call? Yeah, Devansh.
Is it because if an improper fraction is actually like the line means divide, so if you do 8 divided by 5, you would get a number in decimals.
Okay, fair enough. And Ojas, you wanted to say something.
I was going to say that the improper fractions top heavy, unlike other fractions.
Okay, Krishna, you want to say again? Yeah, please. Yeah.
I argue against the lunch.
Okay. Okay, this is not a quote, but I like it. Go on.
You divide 5 divided by 8, it will still give it a small.
Yes, yes. Okay. Shall I tell why it is called improper? I'll go back to my previous statement. When I started, I said, what is the difference between a fraction and a whole number? A whole number is a whole. A fraction is a part of whole, isn't it? Yeah. So it's like something which could not complete. So if I was drawing a number line from, say, 0, 1, 2, and my number is somewhere in between 0 and 1, which means it is less than 1. Yeah. A less than 1 number will have something like 5 by 8. Let's say this is 5 by 8. Yeah, because it's not complete. It couldn't complete one whole. So this is a fraction. And by definition of fraction, even if you take the name literally, a fraction, it is less than a whole. So it makes sense. So this is proper fraction because it is not complete. But when I think about 8 over 5. 8 over 5 on a number line will come somewhere here. Like 8 over 5 is 1.6 if you calculate in decimals, isn't it? So 8 over 5 is actually more than complete, isn't it? More than whole. It's more than 1. So 8 over 5 has got value which is greater than 1. 1 is a whole. Which means by literal meaning 8 divided by 5 is not really a fraction. It's a mixed scenario which includes 1, which is a whole number, and to that we add a fraction, yeah, which is 3 over 5. So 1 plus 3 over 5 basically is giving us, what do? We make denominators same. So this becomes 5 over 5 plus 3 over 5, and then we get 8 over 5. Isn't it? So what we notice here is that this is actually more than a whole. And because this is more than a whole, the literal meaning of fraction doesn't apply to it, which is why it is called an improper fraction. So it is a fraction, yes, but the fact that you cannot divide it completely to get a whole number. But it is more than a whole number and also has a fraction in it. So it's also known as mixed fraction in a way. Yeah, if we express it in this form where part of it is a whole number and part of it is a fraction, it is called mixed fraction. And this is not a true fraction, so it is called an improper fraction. So who raised the hand, please? Any questions? Do you understand what do I want to say here? Why it is improper? Do you understand that? Yeah, because it's not, it's more than a whole, it's more than complete. So there is at least one whole on it in it. If it was a fraction like 21 by 4, yeah, now 21 by 4 is definitely more than 1. And if I try to create it as a mixed fraction, this will look 5, 1 by 4. So 5 whole plus a proper fraction 1 by 4. Yeah, a mixed fraction. So which is why this is called an improper fraction. A fraction by literal meaning is something which is not complete. Okay, everyone fine with this? Shall we move on? Okay, good. So because we are doing topic of ratio today, but if you guys attend the classes in future, I'll go back to some other key topics which come before ratio, but this is a trial class, so I picked up this topic because a lot of kids struggle in visualizing the ratios. Yes, sir. Yeah, you raised a hand. Yes, what's the question, Divansh? You're mute.
I'm just saying, yeah, I kind of struggle with the ratios.
Okay, so think of the fraction also in terms of ratio. If I write something like 3 divided by 5, yeah, you can think of this also as a ratio as 3:5. Ratio, we write a colon in between the two numbers. So we have many ways of expressing a number. Yeah, we can also express it as a decimal, which would have given us like 0.6 here. We could also express it as a percentage. We could have called it like 60%. Yeah, they all mean same. Even ratio, we could have expressed this like 3:5. What does 3:5 mean? It could have meant, for example, I take a mini test, yeah, of 5 questions of 1 marks each. And I ask, and somebody, one of you scores 3 out of 5 in that test. Yeah. So this is as good as saying what is the ratio of correct answers to the total answers. Yeah. So you have got total questions as 5. Correct is 3. And incorrect is how much? How much is incorrect then? Including not attempted. You can say it. Yeah. Simple. Just say it. Unmute yourself and say it.
2.
Yes. Easy one. Yeah. So now The question can be asked to you in terms of ratio. Ratio is like comparing. Yeah, ratio is like comparing. So you have to read the question properly. If the question says, what is the ratio of correct answers to the total questions? So you're comparing correct to the total, in which case you will say 3:5. If the question says opposite, you have to use the same order. So if the question says, what is the ratio of total questions to the correct answers? So first you have asked total questions. So now you will write 5 and 3 will come next. Yeah, you have to go with the order and we will do some questions. Okay, don't worry. If the person is asking what is the ratio of incorrect to the correct, so ratio of, I will write. So usually I like to visualize these things. So how I visualize these things? I write the labels, and it is a very good practice to write labels. So I will write correct. If I ask incorrect first, what is the ratio of incorrect to correct? So I will write incorrect first and correct then. And then against it, I will see, okay, how many incorrect? So 2 were incorrect. How many correct? Under C, I will write 3 were correct. And the ratio becomes 2:3. Isn't it? So you write it in the order. You're comparing two things here. It will come handy in many scenarios. It can be like, what is the ratio of boys versus girls in your class? Or they can ask, what is the ratio of boys to total students in your class? So you have to see, what are we comparing? What two things are we comparing? It could be a question about a recipe. You are making something, 500 gram sugar, maybe 1 liter milk. So, and then that is required for say 10 people, but if you have 100 people, then what you will do? Those sort of questions will come. So you need to know what is exactly that you are comparing. Yeah, and write them in the specific order, write the value against them in the specific order, and you will never struggle with ratio. This you can also express as a fraction later, 2/3. So the first one always comes as numerator. The second one comes as a denominator. Okay, we will attempt some problems. Yeah. So up to this point, are you clear? Okay, before I go to the problem, I'll just give you another example how we do. You know simple fractions? What is a simple fraction? Yes, Krishna.
Oh, I just said that I understood it.
You know it, right? So if I was writing a fraction, say 14/21. Yeah, is it a simple fraction? Yeah, tell me, Divansh.
No, I don't. I think it's a simple fraction.
Simple? Okay. Anybody who thinks similarly or not similarly? Okay. So Ojas has said no. Is fair enough? So what is a simple fraction? So I'm trying to see areas before we cover ratios, because ratios are a lot dependent on fractions, and ideally your fraction concept should be good. So a simple fraction is a fraction which cannot be further simplified. But what do we mean by simplified? So I can see 14 and 21 both come in the table of 7. So there are two ways to see it. Either I can divide both numerator and denominator by 7, because 7 table has both 14 and 21, and this will give me 2/3, and I cannot divide it any further. Because I cannot divide them any further, this is called a simple fraction. So 2/3 is the simple fraction. 14/21 is not the simple fraction, but both of them actually have same value, and which is why they are called equivalent fractions. Okay, so while we learn ratios, before that I'm giving you some concepts, very important concepts of fractions. Okay, So you know equivalent fractions, right? They look different, but actually when simplified, they both have got the same value. So they are called equivalent fractions. But once you are not able to divide any further, for example, if I was taking, say, something like 25, or shall I take a better example? Let me give another examples. Let's say 15 over 75. Now I can see that the last digit is 5, which means it has to be a multiple of 5, isn't it? Yeah. So I divide both of them by 5. And then I get 3 over 15. Is it a simple fraction? We have simplified. Yes, we have simplified from here to here. But is it a simple fraction? Yeah. So why it is not a simple fraction? Because I can see that both can still be divided further by a common factor, which is 3. As long as they have got a common factor in between them, which we can divide further, means we simplify further. And now we get 1 over 5. If you knew 15 stable, you could have directly done it in one step. But I deliberately did not do it in one step because I wanted to show you that many times you may find it in multiple steps because they have got multiple common factors. And essentially this means that 15 over 75, 3 over 15, and 1 over 5, they all are equal. So they are equivalent fractions, but their most simplified version is 1 divided by 5. So this, out of the 3 equivalent fractions, this is a simple fraction, as I cannot further divide it in such way that both numerator and denominator are going to be whole numbers. They have to be both whole numbers. Yeah. And they cannot be further divided. They don't have any more common factor other than 1. Yeah. So you get it? What is simple fraction? Yeah. Look, similarly in ratios, you may get questions where you have got 15 adults in a gathering or party and 75 kids. Maybe it's a birthday party, so kids are more, kids birthday party. Okay, suppose, so and you're asked to find what is the ratio of adults to kids. Now by numbers, you will know adult, kid, 15 is against adult, 75 is against kids. So my ratio is actually 15:75. This is correct answer as long as they have just asked for a ratio. Not an ideal answer because you can simplify it. Just like you can simplify a fraction, you can also simplify a ratio. Because ratio is nothing but a fraction. Ratio is also 15 over 75 here. And just the way we simplified the fraction into 1:5, yeah, so 15:75 can also be done as 1:5. So if the question says, give me the ratio in the simplified form or give me the simple ratio, then your answer will be 1:5 for this question. Do you get it? Who we are comparing? We are comparing adults versus kids. Kids win here 5 times. Yeah, kids always win, to be honest. So 1:5 is the ratio. For every one adult, this also means for every one adult, there are 5 children in the party. So there are total 15 adults and 75 children. Ratio is 1:5, which actually means for every adult, there are 5 kids in the party. Do you get it? Everyone happy? Yeah. Any questions you can ask me. Yeah. Okay. Now we will move on to the questions. So let me bring out some easy questions first. And some of these questions I've shared in my group, so some of you may have seen them or even attempted them and solved them. It may be repetitive, in which case I'll bring some questions from other books as well. Yes, Ojas.
Are we going? Where are we going to mark the answers?
This is more of an interactive class. Okay, so I'm going to either do it verbally. You can mark your answers in the chat as well. That's perfectly fine with me. If you have a notebook or a pencil in hand, you can try to solve them on your own as well and mark the answers in the comments box. But this is no quiz, this is no competition, this is not like who comes first, who solves first. This is a lesson, and I want to ensure that you guys get good concepts. Knowing something is good, yeah, but why, knowing what to do, how to do is good, but why we do that is also important. If your concepts on why it happens, why should we do in this manner is good, you will become expert in that topic. Okay, so I'm happy for you to solve in a paper and put your answer in the comment, but at the same time I'll expect that we are interactive here, and we are also basically listening. Okay, and there will be occasions where I will learn from you guys. Maybe you guys have got a brilliant better method. Okay, Krishna has said these are my answers, but have I shared anything? Yeah, I've not shared anything, right?
Well, I accidentally typed it in.
Okay, so you're ready with it. Okay. I don't know if you have worked on this worksheet I've shared in the group sometime, but I'll just pick it up. So as I was covering one topic on simplifying the ratios, yeah. So first one, what is the simplest term that we can express this as? Okay. Yes, please go on. Who was first? Vibhav? Vibhav was first. Vibhav, I mean Ojas.
I think it should be 2/1. I mean, 2:1.
Correct. Because this is nothing but 6/3, which is 2/1. And good, you can write just 2, but when they're asking as a ratio, what is number 2? Number 2 is nothing but 2 divided by 1. So to get into ratio, we must mention that, and that becomes 2:1. Okay, because we are not solving for a number here, we are simplifying a ratio. All it means is for every unit quantity of this sub object, there are twice the number of other objects. Yeah, good. The next one, 35:20. Always easy way. One way is if you clearly see a common factor, you can cancel out here, or you can express it as a fraction first and then see. So we see that the last digit is 5 and 0, which means it's both are multiple of 5. So I will divide both of them by 5. Yeah, and when I divide both of them by 5, I get 7/4, or I can express in terms of ratio as 7:4. And whoever typed that in the chat is correct. Okay, all good. Next one. This is a bit of tricky one. They are asking you to express in form of 1:n. Very important, because a lot of times you want to know for 1 unit of a certain thing, how many do I have? It can be in decimal term forms also, or in terms of a fraction as well. It can happen. So 4:5, how do we express that as 1:n? Any idea? This is 4, 5. I cannot divide. What do I do now? Any idea? Anybody? No? Shall I help you? Look, for this type of questions, again, a decimal is also acceptable for this type of question. Yeah, no, it's not 4:5n. It is 4:5, but we have to express it as 1:n, which means 4 becomes 1. So what is 5 when 4 becomes 1? Yeah. The answer can be in form of decimals or fractions, as I said. So how I will do this? This is also called, we are building a base for proportion here, not just ratio, but proportion here. No, 4:20 is not the correct answer, because if this is 4, 5, and this stays as 4, the n stays as 5. We are looking for 1:something. Yeah, and this is, let me get the eraser. Yeah. Okay. So 4:5 in form of 1:n. What do we see here? Something is already 4:5, needs to be expressed as n is like missing. I want a number here. What has happened here? 4 has shrunk into 1. So what has happened? We have kind of multiplied the 4 by 1 by 4, isn't it? We have divided 4 by 4. I think dividing will make more sense than multiplying. So what has happened here is we have divided 4 by 4 to get a 1. Yes. So we also, whatever operation we do on one side, to keep the other side equivalent, it's like equivalent fractions. So if I have divided something here, I have to divide by same on this side also. If I was multiplying on this side by a factor, I have to use same factor and also multiply on the other side. This is the concept that will build up for ratio and proportion type of questions. So 5 divided by 4, if we are supposed to give the answer in terms of decimal, I will know that 5 divided by 4 is going to give me 1.25. So my answer can be 1:1.25. My answer can also be 1:5 by 4. Look, 5 by 4 is nothing but 1.25. So what have I done? I've divided by 4. So even for fraction, I've divided 5 by 4. So when expressing in terms of ratio and not a fraction, yeah, a unit ratio where one of the quantities is expressed in unit, 1. Okay? You get it? Yeah, please let me know if you don't get it. I will repeat it. Okay, good. And now we have made it a bit more complicated by saying, what is the ratio of 3:4:1:2 in form of 1:n? Wow. So what do we do here? So for this type of question, let me do it over here. So B, 3/4 is to 1/2. And I have to make it 1. How can I make this 1? What operation? And the operations that are allowed in ratio proportion is only multiplication or division, because the thing either grows proportionally or it reduces proportionally. So it can double, it can half, it can triple, it can be a third, but it cannot be an addition or subtraction. Okay, the only operations allowed here are either a multiplication or a division. So what operation do I apply on 3/4 to make it 1? Do you know? Do I multiply with something or do I divide by something? Yes, Ojas.
Do we divide it by 3 and then multiply it by 4?
Excellent. Because 3 is here on the top, we have to cancel this 3. So we divide by 3. And because 4 is denominator, so we multiply by 4. So what we are doing is we multiply by 4 by 3 both sides. So when we do that, 4 by 3 times 3 by 4 here, ratio 1 by 2 times 4 by 3 here. So I'm multiplying by 4 by 3 on both sides. So this 4 gets cancelled, 1, 1. This 3 gets cancelled, 1, 1. So this is essentially 1. And in terms of ratio here, I can cancel this 4 by a 2. You know all this, right? Cancellation. Yeah, because we are just having multiplication and division, we can cancel out the common factors. If you don't know that, I'll teach you that as well. Yeah. So you cancel out 4 and 2 with the common factor 2, and now you're left with just 2 over 3. So the ratio in terms of units is 1:2 by 3. Understand? Yeah. Shall we move on? Silence is golden. Yeah. Okay. Okay. Let me see if I bring out some different question now. Yeah. And we have got choices here. You can see the question, right? So in Lucy's class, there are 12 boys and 18 girls. What is the ratio of girls is to boys? Yeah, in simplest form. Now see, I have underlined, make this a practice. Underline the key information, okay? Or circle it so that you don't miss out something. Why did I circle girls is to boys? Because if we switch, if we accidentally do boys is to girls, our answer will be completely wrong. For example, 2:3 and 2:3 and 3:2 are completely opposite. You may have solved it correctly, but if you don't follow the question, you will end up with a silly mistake. Yes, Divyansh. Devansh. I can't hear you. You're muted.
Is the answer 3/2?
Yes, very good. So I believe we are starting with easier questions and you're doing very, very well. So, but how do we do it? I know this is a very simple question. You can do it in your brain, but to know the methodology, because the methodology will come very handy when questions start becoming tricky. So the method, the visualization method here is, they have asked for girls is to boys. So write girl first, boy next. Now in the question, see how many girls. So girls are 18. How many boys? Boys are 12. You can see 18 is to 12 is there in the option, but they have asked for simplest form. It's like a simple fraction. So I have to see if there is anything common here. And I clearly see that both of them come in the table of 6. So this will be like 18 divided by 6 on this side. And also on this side, 12 divided by 6, which will give me a 3 here and a 2 here. Because I visualized it in a good order as per the question, I'll not make a silly mistake, and my answer is 3:2. Yeah? Everyone fine with this? Good. I'll move on to the next one then. Yeah. Just give me one moment. Where is my PDF? Yeah. Yeah. So Gertie has 2 grandchildren, Jasmine, aged 2, Holly, aged 4. Okay. And Gertie divides 30 pounds between them in ratio of their ages. So being elder helps here, you get more money. So Gertie divides 30 between them in ratio of their ages. How much do they get? Yeah. So I can wait for 15 seconds for anybody to answer if you want to, and then we will go on with our method. Yes, Ojas.
Is it Jasmine gets 10 and Holly gets 20?
Possible, yes. Okay. We will solve it anyways. So your answer is So I'll say Ojas. Yeah. Everyone has same answer or anybody has a different answer? Look, when choices are given, sometimes you don't even have to solve the question. This is a technique which I will tell you closer to the exams. Okay? Because right now, it is very important that we understand the basics. But when you get closer to the exams and saving time is more important, then we go through option cancelling technique. Now here you can clearly see the total money is 30. Yeah. In that technique, I would see which one are making up 30. 15 and 15 is 30. Okay. But then their ages are different. So their ratio is different. So this cannot be my option. 15 and 7.5 don't add up to 30. So this also cannot be my option. 10 and 20 makes 30. So this could be my option. 2 and 4 will add up to 6. So this cannot be my option. 3 options are automatically cancelled. So by even cancelling the option technique, we can reach out here. But this is something I advise closer to the exam, because then we focus on improving the speed. The time now is to understand the fundamentals, basics, because numbers can become complex later on. And if you don't know the methods, then complex number questions can create problems. So the method here will be, you write J for Jasmine, H for Holly. Jasmine age is 2, Holly age is 4. If you simplify this will become 1 and 2, isn't it? The ratio. Yeah, because money has to be divided in the ratio of their ages, which means Jasmine will get 1 part of it, Holly will get 2 part of it. I will also see total. If Jasmine gets 1 part of it and Holly gets 2 part of it, it means there are total 3 parts, isn't it? Yeah. And the total money that we have is 30. So this 30 goes against the total. Yeah. Getting? Ask me questions if you don't get it. I'm very happy to repeat. Be vocal, be interactive. I don't mind. Okay. This is not a big class which we cannot manage. Yeah. So the total of their simplified ratio is 1 plus 2, 3. And the total money here is 30. What is happening? This is increasing 10 times, which means everyone will increase 10 times. And then we apply that, this becomes 10 and this becomes 20. These are easy numbers, but my focus is on the method. There will be questions which will become difficult. And then these methods will help you, because you need to know the concept that if something is increasing in a proportion, then everything connected will also increase or decrease in the same proportion by multiplication factor or dividing factor. Okay, in this case, it is 10 times. So everyone will go 10 times, and then 10 and 20 is what they get. So Jasmine gets 10, Holly gets 20, and that is the correct answer. Yeah, all happy? Next one coming up. Ratio of men is to women working in a company is 3:5. So even before reading the next line, I can simply write men, women, in the same order, men first, so 3 first, women next, so women next. Yeah, this is the ratio. What proportion of employees are women? Now, employees means total. Employees can be men, employees can be women. Yeah, so we introduce another one for total. So if for every 3 men, there are 5 women in the job, which means total of the 2 will be 8, isn't it? Now you have to compare what proportion of employees are women. So which means we are going to compare employees is total, women is this. So women are 5 out of 8. So out of every 8 employees, 5 are women, which means this is 5:8, or 5 divided by 8, because they have given you options here in terms of fractions. Easy? Good. Okay. 2 more questions and then I will start making them a little more tricky. Let me get both of them. Oh no, one of them. If I put 2 questions at the same time, then you guys will get distracted. You will start solving and then not pay attention. I don't want that. So ratio of cups of flour is to cups of water. Oh, cups of flour, sorry. I was reading it separately. So ratio of cups of flour to cups of water in a pizza dough recipe is 9:4. So I will say F for flour and W for water. So flour is 9 and water is 4 portions. So this is the ratio. A pizza restaurant makes a large quantity of dough using 36 cups of flour. So against flour, I will put 36. Now, how much water should they use? Yeah. So this is where ratio comes handy, because it says for every 9 cups of flour, we have 4 cups of water. So every 9. So how many 9s we have? We have 4 9s here. So this is times by 4. If this is timing by 4, this will also time by 4, isn't it? That is what we learned so far. Yeah. This will become 16 and your answer will be A. Yes. Devansh.
I was going to say 16.
So in interest of time, so that we can try to solve as many questions as possible, even if I know that you can do it, I'm trying to go ahead. Yeah. So even if you know, just listen, maybe sometimes, and observe the visualization and make it very clean. When you do it in your rough work, I advise write very clearly, because you know what happens if you make a mistake somewhere, and if you have written a very clean work, rough work, in a clean way, you can spot your mistake easily. First thing, you will not make a mistake, highly likely, if your work is clean. Even if you make a mistake, it will be easy to spot, and you don't have to solve the question from start. You can resume the question where you made mistake and go on. But if you have done a messy work all around, you will get lost and you will have to solve the question all over again. Yeah. Okay. Very common scenario of questions. The angles in a triangle are in ratio of 3:4:5. What is the size of each angle? For this, you need to know the property of triangle. Do you know what is the sum of all angles of a triangle? Raise the hand first. Okay. Ojas.
The sum of triangles is 180.
No, sum of angles in a triangle is 180.
Yeah, 180 degrees.
Very good. Very good. And I believe both of you who raised hand also have the same answer. Yeah. Good. So now what is happening here? 3 angles. And if I would have said those angles are like A, B, C, and total. Now I don't know what those angles are, but I know that their total has to be 180 because this is a triangle. And now in the question, all I know is their ratio. So A, for every value, 3 value of A, value is for B is 4 and C is 5. Yeah. What is the total? Because we only know the total. So we will take the total of the ratios as well here. So now here it's not ratio between 2 things. It's a ratio between 3 things here. Yes, Ojas.
I think I got the answer for it.
Okay, hold on for your answer. Yeah. So the sum of these 3 angles in terms of their ratio is 3 + 4 + 5, which is 12. Yeah. Now, what is the relationship between 12 and 18? How is it increasing? I know that 12 times 10 gives me 120. and 12 times 5 gives me 60, which makes the total 180, which means it has to be 12 times 15, which makes 180, isn't it? Yeah. So it means that we are actually multiplying by 15. And that is what we have to do with all the components. If you have done this visualization, you will never make a mistake. 15 times 3 will give you 45, 15 times 4 will give you 60, 15 times 5 will give you 75. Do we have that answer somewhere? Yes, we do. Is that the answer, everyone? Yeah. So do you understand? See, this is very easy method. If you visualize it correctly, I know everyone can do these questions, but half of the kids make silly mistakes somewhere. Either they put a wrong order or they're not able to see, am I multiplying or dividing? But if you're doing it in a visual way, like a column way, you're not going to make a mistake. Okay. Now I'm going to okay, let me take this question. So I'm reading many different papers, so I'm bringing some questions from different papers. Okay. Paint Pro makes pink paint by mixing red and white paint in 3:4 ratio. Okay. So as soon as I read that statement, I can see red coming first, white coming later. So I will say red and white for Paint Pro company is 3:4. Color Co makes pink paint by mixing red and white paint in different ratios. So Color Co is doing in ratio 5:7. It says which company is using higher proportion of red in their mixture. So higher proportion of red. Yeah. Very important that you see that red and white are two different colors. So the proportion of red in the mixture, it is talking about red in the mixture. So mixture is total. Mixture is total. So you create a column for total here. Total. Yeah. So 3:4, if they were in that ratio, the total would have been 7. Got it? And 5:7, the total would have been 12. Which means for PP, the proportion of red paint in mixture would be 3 divided by 7, because 7 is the total. Red is 3 out of that 7. Remaining is white. And in the other company, the red is 5 divided by 12. One way that you normally do is to compare two fractions is make the denominators equal, right? Yeah. I will do it in two methods here. Yeah, Ojas, please.
Are you doing LCM?
Yeah. So two methods here, and I will tell you the trick method, which some of you may like it, some of you may not like it. We will see. Okay. So first method is the LCM method. If you don't do it by LCM, you can also multiply them together. Yeah. So if you're going to do LCM method, you don't even, when you're comparing just two fractions, not more than two fractions, you know, the LCM, there is no common factor here. So basically it is the product 84, isn't it? Yeah. But you don't really have to do 84. You don't have to write that. You can simply do sort of a butterfly here. So 3 and 12 will give you 36 for the first. 5 and 7, 5 times 7 will give you 35. Because even if you were doing by 84 common LCM, your answer will be 3 by 7 is equivalent to 36 by 84. 5 by 12 is equivalent to 35 by 84, isn't it? Yeah. Which means this is greater, which means 3 by 7 is greater. So answer is Paint Pro in that case. Yeah. Is everyone with me? Yeah. In this case, I believe this method was better because there were only two fractions to compare with. In many cases, there are many fractions to compare. Maybe the question is order the fractions from lowest to highest. Yeah. So I usually tell a different method to kids in my class. You know what I tell? Multiply the numerator by 100. Sometimes 10 is also okay. Because and then just divide it. Forget about the remainder unless the whole part is coming equal. Now, if I divide 300 by 7, I will get 4. So let me do 300, 7. So 4 gives me 28, 2, 0. And then 7 times 2 gives me 14, and 6 will be remainder. Isn't it? So I get 42 something. I get 42 something. I leave that something. If I did the same for 500 by 12, so 12 times 4 gives me 48, 20, and 12 times 1 gives me 12. 8 is remainder. So it is 41 point something. Now you can clearly see this is bigger, which means this is bigger. This comes very useful. In future, I'll give you examples when there are 5 different fractions, or even sometimes they mix it up with percentages, decimals, fractions. This technique comes very handy there. You don't have to divide something. Yeah, I mean, something as a fraction. People make a lot of mistake when they are dividing. They're trying to do this division and get an answer in fraction. But when I will multiply everyone by 100, I will also get a whole number. And usually by multiplying by 100 and then dividing, the whole numbers will be different. I don't even have to care about what is the decimal part. This will come very handy in those questions. Okay? You like it? But in this question, this was a better method because there were only 2 and it was quite easy. Okay? Okay, in best interest of time, I'll now move to a different type of questions. I like this one actually. Do you know a bit of algebra? Have you learned a little bit of algebra? Sometimes we use that as well. Now look into this question. Ratio of pink socks to blue socks is 3:4 in a drawer. Yeah, now we are making questions a little tricky. So ratio of pink socks to blue socks is 3:4. So as I don't read the rest of the question, you know, I start translating the question as if I'm translating from one language to another. Yeah, for example, if somebody asks you to translate from English to Hindi or any other language, you will translate word by word. I'm translating from English to maths. So my translation from English to maths is like, I'll just write P for pink, B for blue, 3 under pink because that's the order, 4 under blue. That's it. This is my translation of line 1. When I do this, I don't have to read the question again and again. I have documented it. If I get stuck, I can just go to my documentation. I don't have to go to the question again, if I make that a habit. Then the second line says 4 pink socks are added to the drawer and the ratio changes. We'll come to that. But in this case, I know the ratio is 3:4, but I don't know the exact number of socks. The exact number of socks could be 3, 4, 6, 8, 9, 12, 12, 16. So this is going in table of 3. This is going in table of 4. It could be any. I don't know which one. Yeah. And I cannot make 100 of entry for 3:4 because there are unlimited number of equivalent fractions, which is where I use a little bit of algebra. So what I say is the ratio is 3:4, which means the socks will be in ratio of 3x:4x. Isn't it? Yeah. So if x is a number here, any number. For example, if the socks were supposed to be 9 and 12, I don't know the real answer. Okay, I'm just guessing. So this 9 is nothing but 3 times 3, and this 12 is nothing but 3 times 4. The ratio is 3:4, which means this 3 is my x in that case. So 3x, 4x. X is 3, so it will become 9 and 12 in that case. If x is 4, it will become 12 and 16, and so on. Isn't it? So I just convert that 3:4 ratio into 3x and 4x. And why I'm doing? Because they have not given the total number of socks. It could be anything, and they're changing. They're changing the numbers here. 4 pink socks are added. So this is now, and this is later. If the question says original, I can say this as original. So original is 3x and 4x. And pink socks are added. So pink socks become 3x plus 4. Yeah? Because x can be anything. I'm just adding 4 socks to 3x. Yeah? Nothing happened to the blue socks. So blue socks remain same. And when it says they become even, even means even. Now it's not this, it's not this. When the weighing balance is even, it means they are equal. Yeah? So even means equal. It means 3x plus 4 is equal to 4x. 1:1. Isn't it? Yeah? So 3x plus 4 is equal to 4x. So what does that mean? So if 3x plus 4 is equal to 4x, if you know algebra, in algebra, like terms, all the x's we move to one side, all the constants we move to other side. Yeah? So because 4 is bigger than 3, the coefficient of x, 4, here is bigger, I will move this 3x to this side. And you should know when you move this side, the sign changes. Does everyone know that? Or I can tell you why the sign changes. It's like you're subtracting 3x from both sides. So two sides should remain equal. So same operation you perform on two sides. So 3x minus 3x will cancel this out. And only 4 will remain here. And this side will be 4x minus 3x. 4x minus 3x is x, which means x is 4. If x is 4, I can put this back here. 3x will become 12 and 4x will become 16. So originally I had 12 pink socks, here 12, and 16 blue socks here. That will be my answer. Yeah? It's very good practice to check. So if I have got 12 pink socks and 16 blue socks, is my ratio 3:4? So I see that 4 is common. I divide by 4 both sides. So I get 3 here and 4 here. So this is correct. So check 1 is done. My check 2 is what happens if 4 socks are added. So if I add 4 socks to pink, 12 plus 4 will become 16 and 16 blue socks remain 16. Even. They're equal. So my second check is also done. So when I get my answers, it's a good practice to go back into the question line by line and see if everything is making sense with my answers. And it did. So I'm confident that I solved it correctly. Got it? Yeah? Okay. Let's move to a similar question. Yeah? It's always good to practice similar type of questions because then with practice you become an expert there. Mia and Ria have marbles in the ratio of 4:5. Mia gets 12 more marbles and now the ratio changes because Mia gets more marbles. Now Mia's side has become bigger. How many marbles did each girl have initially? So Mia and Ria have marbles in ratio 4:5. I'll translate that into maths. Mia, Ria, 4, 5. Correct? Same method. I don't know how much Mia has and how much Ria has. Only thing I know is the ratio 4:5. So Mia becomes 4x and Ria becomes 5x. This is initially. The question says initially. Why I write this? So that when I get the answer, I get my x back here, calculate it, and I'm able to answer what they have asked initially. Yeah. So initially 4x and 5x. We are okay till this stage? Now Mia gets 12 more marbles. So when Mia M gets 4 more marbles, she now has 12 more marbles. So she has 4x plus 12. No change to Ria's marble. Yeah? Yeah? So Ria's marble remain 5x. Yeah? What does the ratio change as? Ratio change as 6 and 5. So now this is same as 6:5. Fine? Are we all good? The method here is when you compare fraction in terms of algebra, and you know that 4x plus 12 is to 5x is same as 6:5, you can put a bar under it and treat it like a fraction and put a equal to sign. Because 4x plus 12 is to 5x is same as 6:5. So 4x to 12 divided by 6 will be equal to 5x divided by 5. Remember this. And then you can solve it here. 4x plus 12 divided by 6 is equal to, I can cancel 5 and 5, isn't it? In a fraction is equal to x. Now multiplying both sides by 6 so that I am fair to the both sides, multiplying both sides by 6. So why I'm doing by 6? Because my denominator is 6. I want to get rid of my denominator to make my algebraic equations easier to solve. I try to get rid of fractions wherever possible because 6 was dividing. That is why I multiply by 6. When I multiply by 6, this 6 gets cancelled and only thing remaining on this side will be 4x plus 12. And then 6 will be multiplied by x on this side. Yeah? And just like we remove 4x from both sides because 6 is bigger here. So I want all x's on this side, constant on this side. So 12 remains here. 4x moves. When it moves other side, it becomes minus. And this is equal to 2x. So 6x minus 4x. So if 2x is equal to 12, it means x is equal to 6. If x is equal to 6, I go back what is initially. So 4x becomes 24 and 5x becomes 30. It means Mia had 24 marbles and Ria had 30 marbles initially. Yeah? Then the better thing, check. Is 24:30 simplified to 4:5? If I divide by 6, I get 4:5. But what happens if I add 12 marbles to Mia? Adding 12 marbles to Mia will make it 36 of 30 for Ria. So 36 and 30 have 6 common as a factor. So if I divide by 6, I get 6 here and I get 5 here. So which is a ratio of 6:5, which means both checks done and satisfied. So my answer is correct. Get it? Good. We have some more time. So I'm trying. Yes, I'm trying to get a slightly more situational now. I'll share all this worksheet and the worked out worksheet with you after the call also. Okay, and this call is also recorded if you ever want to go back. Okay, so Michael and Tyler share some sweets in ratio 5:3. So as I always like to do, I translate it. Michael and Tyler 5:3. Because I don't know exactly what number sweets they have, I make this as 5 times x and this as 3 times x, and this is, as the word says, initially, which means I have to come here after I get value of x. I should come here and get 5x and 3x to be able to solve, give the right answer. X is not my final answer. My final answer is 5x and 3x. Yes, do you have a question? No. You're doing something like this, so I thought you have a question. Okay. So now this is initially, and what happened later? Tyler gives 3 sweets to Michael, which means Tyler has 3 less sweets, so 3x minus 3. And Michael has 3 more sweets because Tyler has given the 3 sweets to Michael. So Michael now has 3 more sweets, so Michael has 5x plus 3 sweets. Yeah? Okay. Now, when this happened, the ratio has now changed. Isn't it? The ratio has become 7:3. Who is same? 5x and 3x is a different thing. They had this situation, so I'll box it here. But 5x plus 3 and 3x minus 3 later is equivalent to this ratio, 7:3. So this will be in this box. And how do I solve it? I just make them a fraction and equate. Same method. The only difference in this question is that one person gave to another person. So both value changed. Tyler's value decreased, Michael's value increased. Okay. So now when I solve this is a bit complicated because we have got algebra, we have got multipliers, we have got a fraction. To get rid of that, I multiply this side. So basically, this 3 can go to the other side. So I multiply by 3 and I also multiply by 7. Because I have 2 denominators here, 7 and 3, right? So multiply by 7 and multiply by 3, both sides, because those are my 2 denominators. So when I do that, I get 7 times 3 times 5x plus 3 divided by 7 equal to 7 times 3 times 3x minus 3 divided by 3. Yeah? Everyone okay? Am I too fast? Okay, good. So now you can see 7 can cancel this 7, 3 can cancel this 3. Isn't it? Yeah? And now I can simply open the bracket. So 3 times 5x will give me 15x. 3 plus 3 times 3, and in between there is a plus sign, will give me 9. 7 times 3x on this side will give me 21x. And 7 times 3 will give me 21. And there is a minus sign in between. Yeah. I just notice which one has a bigger x. I keep that side for x and the other side for constants. That's my usual practice, so that I don't deal with negatives, as less as negative possible. So this 15 goes here, this 21 goes here. So when that happens, this becomes 21 plus 9 on this side. So this 21, because it is minus, it becomes a plus 29 on the other side. And 21x was already here, but 15x moved to the other side and it changes sign as always. So this is 30 equal to 6x, which means x is equal to 5. But this is not my answer. My answer is initially. So I go to the row which is saying initially. So it is 5x and 3x. So 5x is 25 and 3x is 15. So that will be my answer. But again, let me check. 25 and 15. Yes, it simplifies to 5:3. What happens when Tyler gives 3 sweets to Michael? So this was Michael, this was Tyler. So Tyler gave 3 sweets to Michael. So Tyler has 12, Michael has 28. So what is the ratio? 4 is common here. So if I divide by 4, 28 divided by 4 gives me 7, 12 divided by 4 gives me 3. So my ratio is 7:3. So check done. Both checks done, which means my answer 25 and 15 is correct. Get it? Yeah? Everyone okay? Getting confident with ratios? Yeah? Any questions? Do you benefit from this class so far? Good. I mean, that is all I want. That motivates me when students get the concept and they start feeling more confident on that topic. And I really want to smash all the questions in any exam. So I prepare my students for all type of questions. This is nothing. This is still easy type of questions. Gradually, we will train for the more difficult type of questions as well. So I'll try to wrap up with one more question. Okay. Not too difficult. Just the average age of 3 boys is 12. You know the averages, right? Yeah. So if average age is 12, what is the total? Total of ages will be? Anybody? If average age of 3 boys is 12, what total age? Yes, Krishna.
The total age will be 36.
36, very good, excellent. Many ways to solve this question. This is just one of them. The average age of 3 boys is 12, which means total age will be 36. Now their ages are in proportion 1:3:5. So 1, 3, 5. The total is 1 plus 3, 4 plus 5, 9. And total we saw is 36, which means the total is multiplying by 4. The total of the ratio proportion in reality is multiplying by 4. So everybody gets multiplied by 4. They are just asking the age of youngest boy. So we don't have to care about these two. We just care about this person. So we multiply by 4 and we get 4. So our answer will be 4. Yeah. Okay. Anything else that I could? Okay. One good question I wanted to actually do before I wrap up the class. Ratio of A is to B is 5:12. B is to C 6:5, and you have to find A is to B is to C. So they have not given them together. They have separated them out, and now you have to find them. So what you do, again, visualization, A, B, and C. Okay. The first one say A is to B is 5:12. 5:12. And the second one says B is to C is 6:5. 6:5. All I need to do is see who is common. B is common, isn't it? Yeah. So that holds our key. The person who is common holds our key here. So all we need to do is equate them. So if this is 6:5, in that case, if B was 12, which means times 2, C would also have to go times 2, has to become 10, because 6:5 as a fraction is equivalent to 12 by 10, isn't it? Isn't it? Yeah. Now see, 12 is common. So for every 12 parts of B, we have 5 parts of A. Every 12 parts of B, we have 10 parts of C. So we can join this. And our ratio of A is to B is to C will be 5:12:10. A lot of times this question comes in exam. This was easy number. All you have to do is find their LCM. You have to find their LCM and put the LCM in the middle, and using that, then convert each of those separate fraction, individual fractions or ratios up to that LCM. Okay. And then when that becomes a common, like this became 12 here, then you have to just, I mean, I could possibly make this little different. For example, I could say A is to B is 3:8. I'm just making up any random question. And B is to C is, I'll say 12:7. Find A is to B is to C. So who is common here? B is common again, right? A, B, C. A is to B is 3:8. B is to C is 12:7. Isn't it? Who is common? Common is B, 8 and 12. So I will take LCM of 8 and 12. LCM of 8 and 12 will give me 24. Very good. So now I'll make everyone 24 for B. So if B had to become 24 here, A would become, because this is 3 times, so this will also go 3 times, and this will become 9 here. Yeah, and this will, because this will, to make this 24, this goes 2 times. So this will also go 2 times. This will become 14. Now 24 is common, so we'll take this part, the common part where B is same. So our proportion will be 9:24:14 as answer for this. Yeah, got it? So that was our last question for the day. And when I click this, it will send me an email, which I will forward to you guys, the working of today's class. Yeah, I hope you really enjoyed the class and you feel more confident about the questions on ratio. If you have any doubts, any questions that trouble you on this topic, please feel free to send to me. When I get time, I will maybe make a small video or explanation and send it over to you. And if you're interested in more classes, then your parents can contact me. I can take some other subjects also. Why are you crying? Don't cry. Okay. So anything that you want to say, you can say now before I wrap up the class and disconnect. Yeah, you can unmute yourself if you want to say something. Any doubts? Yeah. Yeah. Yes, Krishna. Unmute. Okay, nothing. Okay. So everyone fine, right? Okay. Okay. So I enjoyed the lesson and I hope you too. So I will wrap up this now and I will also stop the recording. Where is the recording? Stop recording.